Hi, how are you? I hope you are fine. I know that this was a very long time of my last video. I have so many troubles, but I'm here again. So the last topic that we were talking about was for flat belt calculation. The last video was on Spanish, so now it's time for English part. So let's start it. Well, this is an example that have different situation. The part of the equation it's kind of similar for chain transmission. The only difference is this is for belts. So this is the example. Listen very carefully the different situation that we have here from the data. And well, this also will help you to design for when you start to design or select when your maintenance maybe job, I don't know, and it's gonna be very helpful for you. First, well, there's a transmission step for mass. Oh, here is mixer. Sorry, this is for mixer. The capital consumption of 7.5 kilowatt with 288 RPM. So this is just a transmission by flat belt. It's gonna be a start at intermediate shaft with a same speed that a mixer. So we here should read very carefully because he says two steps. Oh, sorry, I didn't put it. I have in my mind. Two steps for a mass mixer, and we have this data. So the data set first step is a belt transmission. The second step chain transmission. Center distance we have this is a range, and about the sprocket pole diameter we have another range, and we have a three-phase motor with a direct start. Sorry, here direct start, the power and what RPM speed. So this our mission is here's a situation if a mixer works the working hours have 28 hours per day with 40 degrees so and different impacts. So that means when the exam began of the motor, he said we need to select the best the best belt of the brand Anchor G Rowlet for this system. If we wanna understand the situation of the this is a picture that we have viewed for us. You know that this have two different steps. This is should be our mixer. Let's put another color. Sorry, this is for us our mixer, and that means that have so the first step is belt, second step transmission. So that's the reason why here we have a pull belt or with pulleys, and in the same shaft of here we have well, the sprocket for change, and this is our change, and the mixer. So this is a driver, over here is driving pulley. So this is a situation if you want to understand it. And you know you have the flat transmission have the same speed that the mixer, so that's the reason why we have here the same shaft. So that means. So for the equation we have this. As you can see, it's kind of similar for the last chain transmission. So let's start it. Something that we have to know that this data of the chain transmission is from here, but we only need to know that it's the same speed and the first time is better transmission. So we don't need too much actually. We only need this. This 288 for the mixer. This is the speed of the mixer, and we three-phase motor we have 865. So with this information we are gonna have our radio. Oh well, I'm here. That's the reason why. I have that sample that is gonna have you. This is the speed 865, 865. That means here we have this the motor. We have this is the ignition, the first step of all this movement of the transmission. Then we have a radio. Then it's gonna be a reduction of the speed, and then here we have a mixer. Well, as you can see, we have a radio of 3 That means this is 3 times of 1 speed per second. And then have a sprocket pulley. That means here we have a range. Actually, how we should select. Well, this is a Roland. This is the Roland VDF for Roland, as you can see. This is the for flat belts. It's a good brand. I recommend you. Something that we should know is from here. We have 3 different diameter for commercial diameter that we should know. So if we should for this example actually ask for Dancord G, but you have a different Dancord H. So in this case we should check here, and we don't know what is the first diameter that we need, so we can actually put the first. In this case is 160. So let's start with this. We put 160. We have that. We have with the radio. We have the driving pulley. Sorry. We have the driving pulley, and we have a certain distance, and this will be okay, a good center distance. But there's something that we have here, that we have a range, and 961 it's not in this, so we should change our sprocket diameter. So the second commercial is 200, so let's put 200, and as you can see it's this 1201, it's in our range, so we can use 200. Actually it's okay, it's okay. Let's see with the next one. It's 250. Too much, as you can see, too much. So let's put only 200. We have a driving pulley diameter, the center distance, and we have let's start with the calculation of belt length. Here you have the equation, how to use it. This is 2 times the certain distance plus 1.57. This is a summatory of 2 diameters plus this is a difference. I don't remember how to say it in English actually, but you know it. Divided by 4 times the certain distance. So this is, you are gonna use it, as you can see. Well, this is Excel makes everything. You should only check it. And then we have this, but then we need to know if this is a commercial length. So we have to round. We have this as sorry. Oh, okay. Sorry, this information it's not here. I remember. No, I only remember that you should round up. I don't know if it is a correct expression for the next part number. So for ours is 369.94. Okay. We have some recommendation for the brand. In this case, for Dancord, the max speed it's 40 meters per second, and this from here, as you can see, for V-belts, flat belts, you have a maximum speed of 40. In this case, well, this is only for notes, because you can also calculate with the speed 1, as you can see, for the first RPM. This is in RPM. You have the diameter, so you could also calculation with the speed if you want in meters per second. Only to simple calculation. This is something for the brand actually that you should know. This is for minus 30 until 60 degrees, but something that you know it's in 40 degrees only. It's okay. Don't worry, we don't need too much. This is something that I call inlet factor. That is a equation that from here. So as you can see, there's no name here. and I didn't know it. So I only put to calculate this. We need this. This is our inlet factor. As you can see, difference of the diameters, and you need the center distance. So you know this 0.3335. Okay. Then you need the arc of contact. You need, well, the net data. So this is to calculation our arc of contact correction factor that is from here. So we have 0.3335. So it's from here. We have to do we have to make an interpolate from here. So let's put it. We have 0.3, 0.3335, 0.4, and then we have 163 and 157. 163. Okay, we have this. As you can see, that's the reason why I put here. This is only for mathematics. You need to know how to make an interpolation actually, but if you want to see it, it's from here. Okay, we have the arc of contact, and then we can also select our, from the second table, our CTC2. As you can see, we have our arc of contact, and we are gonna make the same actually to calculate our correction factor. We have 0.93 and 0.91. So let's put it 0.93, 0.91. We have this. As you can see, the same. I'm doing the same. We need to be very exactly with the number in this case. And then we are gonna put a service factor. It's the first table, and this is we have to analyze. Why? Because let me put it kind of some. Okay, this is the table. Okay, we need information like working hours, as you can see. Okay, we need working hours. We did these different impacts, and you can see different impacts. We have another information that we have you direct start, free motor or free phase. Sorry, a motor with free phase. So we are here. 20 hours. So number of operator over 16. We are here. Where we have a free phase motor. We are not in this case with combustion engine DC shunts. You know it. We are here actually with direct start motor, as you can see. So this doesn't have a variable frequency, maybe something like that. We are here. Then you should only read it. Agitator for liquid, small centrifugal blowers, fans, something like that. We have belt conveyor. We are not here. Grain. You have different examples, but as you can see it, we have some mixer here. So we are in this group. Vibrating and rotating screen. Not only the screen, maybe some kind of different machine, but we are here because it's a mixer. This is for more different. Well, this is more heavy machines, so we are not here. If we are here, so 1.4. It's the number that we need. As we put here, 1.4. The same. Power rating, each 10 millimeters. We have another table that is table 3, and we are here. We have the power rating that we should check. So we have different revolutions. As you can see, we have 65 and 288. We have the different power rating. So we should put here. Number of revolution, we are for here for 200. It's our sprocket diameter. We should put 868, I think 65. It's from here. You can see. So we should put only 800. Here we have 865, and we have 890. I think 890. No, 920. Okay. data is 1.81 2.0 1.81 2.08, I think. Yeah. Okay, so that's the number. You can see the interpolation. This is how I got it. Our motor power, it's in kilowatt, and you can see, because here in Latin it's in kilowatt, no horsepower, but it's the same. 9. So we can calculate our belt width. This equation, it's only, as you can see, it's 10 times our service factor multiply our power motor, and this is one you divide it our power rating uh, multiply by the factor, your arc contact factor correction, so you have your belt width, and you should check it if this is something commercial, so you have to write up and check it on the table. If you if there it's here, you have some recommendation. As you can see, we have 69 point something that we are not here. We are the next one, 71. So it is. So that's all the calculation and equation that you need for this in this case. So if we should answer something this, well, how can we put it? As you can see, we have 3 different answers from here. So our first answer is we have one. I'm gonna put the principal pulley of 71 diameter. Sorry. No. 71 millimeters of belt width. No. Of width. For flat belt with 200 with a flat belt with diameter of 200 millimeters. Okay, this is gonna be the same, but actually you have this, but you have a driving pulley. Actually, you have a driving pulley of with the same belt with the same width. We have as you remember, I think I don't remember here. Okay, 601. And for our second, this is the same information that I have here. To finish, I have one flat belt. Well, no. One Dancor G flat belt of 71 millimeters width on 360 here. 394 360 I remember, and okay, this is the information that we have it. This is our answer. So as you can see, when you are designing, you have a situation this in real life. You as engineer, as a student, also you can do it. You need this kind of information, so you should maybe investigate something like how many working hours that you're gonna need your machine, something like water temperature, something like, I don't know, how many you want and what is your range in a certain distance. Maybe you need a layout of the space that you are gonna need that machine, something like that. If you need imagine that your boss maybe or some chief of your area told you that for economy types, you need to reduce the cost of this design. You should, maybe that means that you should use the minimal option. That could be the, I don't know, the first in this case the first pulley, maybe, I don't know, depending of your situation, because more diameter means it's expensive than the first one. So it's something like that. You need to change it, check it also, if what the place that the machine is gonna work, where it's gonna be assembly, the alignment, something for this case for different impact. So you need to check it, but it's that information is something that you are gonna study, that you are gonna investigate when you have a real situation in real life. I hope you that this example help you a lot. If you have any question, do not hesitate to do it. Um, I'm gonna try to make more videos in every week. Actually, when I don't make a video, it's something that I have I have no time with the work, for the job, maybe for with the family. So patient, but I'm gonna try to search all the information that I have. Have a nice day. Be huge for you. Bye bye.